Okay, thank you so much. So I will go ahead and get right to it. So next slide, please. So this is the outline of the talk. I'm, of course, just briefly going to give a background of the program, some of the very recent research highlights that I think will be interesting to the consortium, and then talk about the 2022 exclusive lines. Next slide. Yeah, so program focuses largely on chili, with us to a smaller extent sweet pepper, and now we are exploring habanero or Capsicum chinense. But let's say 60–70% of the work we do is targeting chili, with a focus of South and Southeast Asia as our major beneficiary. And this has been a goal since the initiation of the WorldVeg pepper breeding program more than 35 years ago. Next slide. Yeah, so Pepin showed this slide already, but I just want to highlight this in combination with the next slide. So yeah, according to stakeholder feedback, there's undoubtedly no question that Bagomo virus resistance is a top priority, followed by anthracnose, high temperature, stress, and then thrips, sorry, and then finally in the top 5, yield. So we have 4 disease resistance, or let's say biotic stress resistances, that are higher priority according to the consortium than yield. So I think this is quite interesting, and it really pinpoints the role, I believe, of the WorldVeg pepper breeding program in this consortium and beyond. I think what the consortium needs from us is sources of good resistance and adapted backgrounds that can be rapidly used in your program. And so this is definitely our goal. Next slide. Yeah, so some of the major stresses we focus on, of course, the virus is number 1, Bagomo virus, which has been initiated in the last 3–4 years in full force with a hiring of Dr. Manoj Kumar, who is handling the Bagomo virus breeding program here in India. But also we work in potty viruses and Tabomo viruses and cucumbo viruses as well. We have a pretty strong anthracnose and Phytophthora breeding program. Bacteria wilt, bacteria spot, mostly in sweet pepper. These are, let's say, lower priority targets for us. Thrips has become a very recent target of ours, although it's been a problem for many, many years. And I'll talk about this after the lunch session. I have a presentation specifically on thrips. Yeah, and of course we have high temperature and flooding, CMS and GMS is also always there. Next slide. So I want to talk a little bit about some of the work we did in the past year on powdery mildew. So we found several lines to be tolerant in our fields in Taiwan, although we don't have a way right now in headquarters to artificially inoculate with powdery mildew. This is quite a complex pathogen, so it's truly a field-based breeding program. Unfortunately, I think this is no news to anyone in the room that most of our sources are Capsicum bacatum. But we found one line, PBC 785, which is Capsicum annum, and it's consistently tolerant in multiple years of observations in the field. This means in the high pressure season, it's performing very well, surrounded by susceptible lines with expression of the disease. In the past couple of years, we made reciprocal crosses to S checks, and we evaluated the F2 population, so 140 plants in total for powdery mildew pressure. So next slide. So this is our rating system. 0 has absolutely no symptoms, means the leaves are very, very clear. A score of 1 is where we have 1 to 3 leaves on the plant with small yellow spots, but no white powdery sporulation. In our mind, this is something like tolerance or maybe a hypersensitive response. We're not quite sure. One of the questions I would be interested in is a score of 1. I'll show the picture soon. Would a score of 1 be acceptable in a farmer field or in your breeding program? And then, yeah, of course, a score of 5 is complete defoliation. So this is our rating system. Next slide. As you can see, on the left of the slides, that's a score of 1 there with none, and then a score of 0, sorry. And then score of 1 is there in the middle. I think you can see, I don't have a pointer to show you, but there's a couple leaves in the middle section of the plant with small yellow spots, but no sporulation. There's no white powdery substance. And then I showed there a score of 3 and a score of 4. And I think you can all imagine a score of 5 without any leaves. So next slide. So what we found was that when we evaluated 0 as meaning resistant, a score of 0, we found that inheritance didn't deviate from a 1:3 segregation ratio, indicating a single recessive gene in both reciprocal crosses, so it's not maternal. But when we consider tolerance, which means a score of 1 or 0, what we're calling something like tolerance, we found that segregation was 7-9, so a little bit more complex. So I'm thinking maybe if there is if a score of 1 is acceptable, there seems to be possibly some dominant gene action in addition to the single recessive gene controlling immunity, let's say, in the population. So this is something I want to discuss in the future or later today. Next slide. So I think we presented quite a bit. Roland has addressed it, but this is something that's really exciting to us. So we're talking about it a lot. This is the capsicum core collection that we've worked on with several gene banks funded by the EU Horizon 2020 program called G2P Sol was the project. Basically, they sequenced the entire collection of nearly 15,000 capsicum accessions. And based on diversity analysis, 400 accessions were identified to represent a core collection. It represents the diversity of the 15,000, but in a much smaller, more manageable number. Next slide. I think you skipped. Did you skip one, or is this okay? Maybe go back. Sorry, go back one. Okay, next. And then we next slide. Sorry. So then we phenotype the population using the automated phenospecs that Roland presented in his talk this morning. Using these 3D sensors and we also collected manual data. But basically, we did 3 experiments, and I'll talk about it in the next slide, please. Yeah, so we did 300 members of the core collection that were all capsicum annum. We didn't include the other species because of differences in morphology and germination and growth, but we did focus on annum. We included 3 checks and a randomized complete block design. So next slide. So we did 3 seasons. We did what we call heat 1, control, and heat 2. This experiment ran from 2020 to 2021. And heat 1 was May to June, control was October to January. In Taiwan, this is really optimal conditions for vegetable production. It's cool, it's not very humid, it's drier, so it's a really good season. And then heat 2 was a little bit earlier. And the reason because heat 1, I think we really missed the most severe heat stress we observe in Taiwan in heat 1, heat stress experiment 1. So I pushed the experiment up a month to make sure that we are targeting this high temperature period right at flowering. And this is really important in future slides I'll show. So next one, please. So this is the temperatures observed during the 3 experiments, heat stress 1, control, and heat stress 2. And you can see that red box there on heat stress 2, temperatures are reaching 38, 39 during flowering. And this became really critical when we looked at the data. You could really see a difference between heat stress 2 and heat stress 1. So next slide. Yeah, so on the left, you have our manually collected traits, yield components, leaf temperature, days to flowering, fruit size, all the things that you would expect a yield trial to measure. And then on the right, these are our automated traits. So we measured digital biomass, plant height, leaf area, leaf angle, NDVI, MPCI, PSRI. These are all stress-related traits. So NDVI is associated with overall plant health status. MPCI is associated with chlorophyll content. And PSRI is associated with senescence or carotenoid expression or carotenoid content. And so in total, now this is the rough categories, but in total, we measured more than 76 traits of the core collection across the 3 seasons. Next slide. So now I'm going to steal some work of Yaping, who is here, because I think it's really interesting, and I'm grateful to let me use her slides. But from her analysis, she was able to find the top 10 traits that are associated with yield in our experiments. So our heat stress, 2 experiments and 1 control. I think no one in the room is surprised that fruit number and fruit weight each account for around 15 or more than 15% of yield. But I think the third trait that's associated with yield, the third most important trait that's associated with yield is quite interesting. This is biomass under the growth curve. So this, I think, is not a yield component we wouldn't normally think about in pepper, but it was found to be the third most important trait in our experiment. And then leaf area index was next, final leaf area, and then finally, we have fruit length down, and then leaf temperature is next under heat stress. We know that under stress conditions, healthy plants are cooler and stress plants are hotter. So this is one of the associations. Yeah, and then fruit width is there. So I find this quite interesting. There are definitely things that we know are yield components. There's also things that we wouldn't expect to be associated with yield, but our analysis showed that they make up a significant portion of yield. Next slide. Yeah, and so this is a stability analysis that Yaping did on the core collection, and then also on the top, best, and worst 10 lines. The top, best, and worst 10 lines in the core collection. So you can see those that are blue are highly stable, and those that are red are much more variable between the stress and the control conditions. They're much more affected by high temperature stress as compared to those that are blue. And then you can see the black lines, these are the 2 environments. So the 2 stress environments are going in the same direction, indicating they have the same interactive force on the experiment. And then the control, the cool season, is going in the opposite direction. So this is what we would expect. Next slide. So Yaping also has started doing GWAS using these 76 traits. And what I'm presenting here are a few of those top 10 traits we mentioned to be associated with yield. So we have fruit number, the first 3, fruit number under control, stress 1 and stress 2, and then fruit weight under control, stress 1 and stress 2. Now, I'm not going to go over all the GWAS results, right? I'm just going to show a few highlights. And what I found interesting about this analysis on chromosome 4 is biomass. So there's a significant QTL. So the darker the blue, the more significant. So there was a significant loci associated with biomass in all 3 environments on chromosome 4. But when you look at the top at fruit number, you can see that there's a significant loci for fruit number under control, a significant loci that's different under stress 1, and a significant loci that's different for stress 2. So this is obviously a trait that's highly affected by the environment, and different loci are contributing to fruit number under different environmental conditions. So this is really promising work, I think, and will help inform the breeding program in the future. Next slide. Yeah, and we continue, and I don't expect you to be able to read this slide, but just to show you how many loci we identified for the traits on a single chromosome. So here it's chromosome 2. You can see how many blue lines there are for all the different yield components. So what I was talking about this with someone yesterday is that heat stress is a phenotype made up of many component traits. Each of these component traits are clearly quantitative. There's no qualitative, or it's not a heat stress is not something you can go select for. You have to select for the individual components and combine those into getting a heat stress line. And this, I think, really shows this, just to look at this one chromosome out of 12 for the different traits. Next slide. Yeah, and the same thing for the vegetative traits. So the first one was yield components. These are vegetative traits like leaf angle or color, chlorophyll content. It's basically the exact same picture. Next slide. So in summary, yeah, resistance seems to be controlled. To powdery mildew seems to be controlled by a single recessive gene, although tolerance might have some dominant and recessive gene action involved, or epistatic nature. And I'm curious, is tolerance acceptable to farmers? Yeah, 3 seasons of automated and manual phenotyping have proven extremely useful in identifying important traits for heat tolerance and yield components. And I think unsurprisingly, more than 70 traits were found to be quantitative, with multiple significant loci identified. And of course, validation of these loci will be conducted in future years. I just want to update everyone on the work that we're doing in heat stress and to show you some of the most promising results we're having. Next slide. So what I'm going to talk about now briefly, unfortunately, we can't see them, but these are the 2022 WorldVeg lines that we will be making exclusive access to the seed companies starting very soon. So on the left, we have AVPP 22007, which is a very dark red line with very high ASTA values and moderate resistance to CMV, cucumber mosaic virus, in Taiwan. I think this is a really good source of dark red color in the breeding program. And the next is AVPP 22008. I think this is a snacking pepper market segment. It's quite large and it has a very ease of harvest. The force is only 4 newtons of harvest. So it's quite easy to harvest the fruits in the fields. And we found that it has very high levels of tolerance to many biotic stresses, including powdery mildew. It has very nice flavor and is, one second, and yeah, I think it represents an interesting heterotic group because it's originating from China. So it's a Chinese material and it's a very short stature. So I think it could be a potential good parent for hybrids, making hybrids, because it should be genetically distinct from a lot of the breeding material. Next slide. And then we have AVPP 2006. This I think is a dark green fresh market segment with a lot of tolerance to field conditions. It has a high level of tolerance under our field conditions. And then we have an erect chili. Sorry, we don't have a good picture of this. We only have a picture of the plant. But this erect pepper is extremely pungent and has moderate levels of resistance to anthracnose at the green fruit stage. And I understand that green fruit anthracnose has been a problem recently here in India. So we artificially inoculate our material with Colotriticum acutatum or scobilii. And this line was found to have moderate levels of resistance under artificial inoculation conditions. Next slide, and we'll go into the sweet peppers. So these are 2 different shapes, but both quite high quality sweet peppers, both green to red, with good firmness and pretty reasonable yield, with averaging 14 and 11 fruits per plant. So this is AVPP 22013 and 22015. And next slide. And then these 2 are both resistant to Phytophthora capsicii race 1 in Taiwan, or moderate levels of resistance to Phytophthora capsicii race 1. Race 1 is our weaker race, but it's still, I think, promising in certain conditions for potential use in the breeding program. 22022 is purple to red, and 2207 or 27, sorry, is a nice long bell that is green to yellow. So I think with that, the next slide is my acknowledgements. Yeah. And then with that, I'd like to thank you all very much. And I'd like to open the floor for Roland to take questions.
Thank you very much, Derek. We have now, again, 20 minutes time for discussion. And we have the first questions in the chat box. Is there any morphological difference between
Colotriticum gloeosporioides and Colotriticum acutatum? Okay. There are, I think. Ricardo, do you know off the top of your head? Maybe this is not a question we can explain, but a question we can show, right? Maybe we can send you some slides to show you the morphological differences between gloeosporioides and acutatum, unless Ricardo has. No. Okay. Yeah.
Okay. Then let's go to the next online question. Could you please explain what you mean for what's under the growth curve means?
So we can area under the growth curve represents. So, for example, now I hope I'm visible because I'm going to use my hands. So you can have differences in biomass and growth rate. So a plant that grows like this through the season and then like this would have a different area under the growth curve than a plant that grew like this, right? So area under the growth curve doesn't just represent total biomass, it represents daily growth rate, basically, I would say, something like this. The rate at which the plant is growing. And of course, it also would account for once we hit reproductive stage, the growth rate would be very stable under the growth curve. So differences in this are what I'm talking about when I discuss area under the growth curve for biomass.
Briefly, the earlier a plant is growing rapidly, the larger is the area under the growth curve.
Right.
Now we have a few questions here, Dr. Prasanna.
Yeah, congratulations, Derek, for your work on heat tolerance. I think you had extraordinary collections of hot pepper lines and worked on heat tolerance. So my question is on what would be the possibility of having a good genetic gain using these lines for heat tolerance per se?
That's probably a question for Yaping. Yaping has done most of the analysis as far as heritabilities and things like this. No. Well, I think based on, without talking about statistics, I would say that there's definitely variability in this collection. And with variability, you can begin to make genetic gain. We haven't, I guess, looked at necessarily the heritabilities for the traits, the individual components of heat stress traits, and this type of thing. But I think there's definite potential there, but how likely is, I mean, I don't have a number necessarily.
There's a question from our colleague from Indonesia. Please introduce yourself.
Hi, my name is Nio from BC International Indonesia. So we know that heat and drought are different things, but I'm just wondering whether your heat tolerance stress also have some kind of tolerance to drought. And maybe from your GWAS study, did you see any like common response that you see in heat, as well as a common response in drought? Thank you.
Thanks for this question. So we have not phenotyped the core collection for drought in Taiwan. Drought is not a high priority target of ours, but it is there. I think flooding, maybe we have a little bit of more work on. I know that certain traits like leaf temperature, for example, is really important for drought stress, for assessing the tolerance to drought stress. So I can't really answer your question because we haven't looked at drought stress in this population, but I suspect there's probably some overlap and also some pretty big differences in response.
Ricardo, please.
Just a quick one. Have you checked on stomata density or some other physiological related traits that are connected with heat? Maybe there's an answer there, no?
Yeah, we have not done this yet. So we are initiating our very first growth chamber experiments right now in headquarters, just to get an idea of how this can work. And in the future, we plan to conduct some more. Now, I haven't necessarily looked at stomatal number or stomatal density, but we plan on getting some much more advanced phenotyping on individual heat stress tolerant and heat sensitive lines to make some comparisons in a much more detailed way than we did in the core collection. But I think it's not feasible to do so in 400 or 300 core collection lines.
Let me take in one question from the online audience. Which Phytophthora capsicum race is prevailing in India? Who can answer this question?
I was told recently that there haven't been a lot of race characterization studies of Phytophthora across India, but I don't know how true that is. I don't know if anyone in the audience has an opinion.
We have two species, Phytophthora boehmeri and capsicum. Capsicum is the predominant one. Boehmeri comes more on capsicum.
Yeah.
Bell pepper. Race is not defined here.
Right. We often find, now just for background information, we often find that temperate regions have much more virulent Phytophthora capsicum than tropical regions, but that's not always the case. So you can imagine maybe in the north, I don't know, but if they're more temperate, sometimes we have more virulence.
Hi, Derek. Srinivas, thank you. Nice presentation. So I have a question. So you have 2 lines in a 2022 exclusive lines. These are 22207 and 2200. These 2 lines are having a high ASTA value, color value, but doesn't have a anthracnose resistance.
That's right.
And also the plant type is almost is a very dwarf and both the varieties.
The second one is a dwarf
Yeah.
plant. The first one
Dwarf.
is normal. That's
Yeah.
right. So Srinivas brings up a really important point I want to talk about. That is that our breeding program has focused for many years on Colotriticum acutatum scovillii at the green fruit stage. We are now initiating more population development targeting truncatum at the red fruit stage. This has been neglected in the past. So we have one source that is resistant to both. We got to the F5 population of the reals and we thought, okay, we'll map both truncatum and acutatum. And I've talked about the acutatum resistance in previous years of the APSA workshop. But we found that at the F5, the truncatum resistance was lost. So I'm starting again with an F2, screening for truncatum and making selections, and then progressing that to maybe the F4, F5 to map truncatum resistance at the red fruit stage.
Okay, please go ahead, but afterwards, please pass the microphone to our colleague to the very left.
Okay. 6 of 8 Champlasm you present is a maintenance line. When we resolve the Champlasm, is the A line is available also? Thank you.
No, we focus our breeding program predominantly on the development of B lines, with the idea that if you have an A line already in your breeding program, you can back cross our B line and make your own A line complement to that B line. That's if for us to develop an A line and a B line, is really a challenge based on the necessity to release 8 new lines every year. This would be a big work for us. But I hope that in a couple of years, through backcrossing, you can make your own A line, given that you have an existing A line. But if you need a source of A line, please feel free to email us. We have some stable and some unstable A lines that we can share with you.
Yeah, thank you, Derek. It's very nice and comprehensive presentation. I'm Gopal from East West States. I want to know your line that PBC 785. You are showing that it's powdery mildew resistance. So did you check any combination with that line for checking the drying quality? I mean, the ASTA value especially. Is there any correlation between that resistance level and the ASTA value?
At this stage, no. We haven't focused on the quality traits. We're looking really at powdery mildew resistance in this line. My next step actually would be to send this line to Manoj in Hyderabad and to let him evaluate it here in India before we really move to, let's say, developing this into a finished product to be shared with APSA. I've heard many comments over the years about the importance of evaluating our material in India before release. So this is something that is let's say, the next steps, but don't expect it in 2023. But these are the next steps.
Okay. And another question, your 2 lines, that 007 and 008, it's looking very good for ASTA, but as you said that its background is from China. So
one of the lines is from China, the other one is not.
Okay. So did you check their drying quality in the sun drying? I mean, because sometimes what happen, more ASTA value, but it should not be dry in proper condition. I mean, like the Indian condition in the sun drying. Right. So that's just want to know. Yeah.
Taiwan is, I think, really too humid for sun drying to mimic the normal production system or the normal drying system that we see, let's say in Andhra, on the open ground. We do use artificial incubators or dehydrators to evaluate our plants. So we can consider our ASTA to be ASTA potential, right? With the possibility or under a farm field, it may be reduced if you're doing solar drying. One of the things we're interested in looking at, but I haven't pursued heavily, is retention, color retention over time. This is going to be a big effort for us to try to store all the powder for a long period and check, but this is something I've heard a lot about that we need to focus on. So this is in my mind. Thank you.
Yeah, hi Derek. This is Harshal Pandey from Monsoon Crop Science. Actually, yesterday, what we have seen in the field, especially the line 1609-85.
Yeah.
So you have mentioned here that it was 1,29,000 SHU. So when we checked it into the field, there is a lot discrepancy in that. It might be not around 30,000 or 40,000 or so. So is it like the season or location specific? What is your comment on that?
Right. There's a lot of literature, and I think also personal experience that capsaicinoid production is extremely influenced by the environment, not just temperature, but all stresses, drought, heat, probably disease pressure might affect it. But not only this, but even first node fruit to top node fruit, they're going to have different levels of capsaicinoids, and the capsaicinoids will change during the fruit maturity. So the one you tasted maybe was a little immature, or maybe what we evaluated was over, it's just, there's this trait. We should think about our let's say, capsaicinoid content or Scoville heat units as approximations, with the expectation that we're going to have a lot of variability based on the environment.
Hello, Derek. I am Harbhajan from Syngenta. I have a question for output traits like ST and SHU. Do you have find any correlation if it has high ESTA, then the pungency will be low, and if pungency will be low, then it will have high ESTA. Do you have any material which is having the high ESTA plus high pungency in our collection at AVRDC?
I haven't ran the correlation analysis to determine if ASTA and pungency or capsaicinoid content is negatively correlated, but it does seem like that. It seems like that as you get darker ASTA, you have lower, and this could be the source of dark ASTA. A lot of this Hungarian material was used a long time ago, which is not very pungent at all. So this could be, now, I'm not saying that there's a genetic, that the genes for dark carotenoid production and the genes for capsaicinoid production, I'm not talking about that. But yeah, this is something we're interested in exploring and increasing both capsaicinoid production and carotenoid production into a single line. We're working on this.
Thank you. And one second question is, now in these days, DMC is very important for red dry segments, that is red dry quality. But due to high rains and extreme weather conditions, due to high rainfalls, this is a big problem. A lot of chaff is coming. So while producing in the breeding program, we are expecting that you should have the projects like high anthracnose lines with high CLCV. So
Right.
that will be very useful for the industry.
Right. This is very clear to me.
Thank you.
LCV and anthracnose was 1 and 2. So the limitation we have is that the breeding program is based in Taiwan, and we don't have very significant LCV pressure there. But we're working on it. Dr. Manoj quite well. So he's handling the Bagomo virus work here in India. Anthracnose work, I think we can do in Taiwan. We have very highly virulent strains of both acutatum and truncatum that I think we can screen our material for. And it seems to be holding up. We've done previous experiments of multi-location trials of our sources, and our source of resistance is holding up in 5 locations in India, Thailand, Philippines, Vietnam. So I think anthracnose we can do, and then at headquarters, and then Manoj is handling Bagomo virus, and then we combine and start to release this material to APSA in the future. Moderation, very easy for you.
Hello, Derek. Myself, Kalyan from North Baijin. My question is about leaf curl virus. Yesterday, whatever we have seen, the 4 lines, have it is screened in hotspot areas?
No.
So it should be, and then we will claim the.
Right. So as I mentioned yesterday, we really cannot screen the material in the location after release. We have to release first, and then it gets screened. This is the model that we have to do based on APSA, phytosanitary requirements, and a million other components. We can screen breeding populations in the hotspot and then use those products of that, the resistance identified in the hotspot in our breeding program to release lines in the future. But we can't screen we used to have a program called ICPN, but this had to be stopped because of phytosanitary law change. And it's basically impossible to pick this up. So yeah, I'm sorry about this, but this is the way of the world.
Hello, this is Pathak, CS Pathak from Nath. I have a question about thrips. The original thrips, which has been troubling in the past, and now this black thrips, of course, probably we are launching some project and all that. My question, do we have any knowledge about the black thrips, from where it has come, or, I mean, there is any lack of phytosanitary or something somewhere? That is one. That is probably the area where we have yet to look into that, so that in future we don't get such problems. Because this year, we had very devastated situation because of that.
Thrips parvispinus, from what I understand, is called also Southeast Asian thrips.
Yeah.
And I think it's been in Thailand and that area for many, many years. How did it get to India? I have no idea how it came here, and how it, so maybe there's some people in India who can discuss this. What we are finding, and I'll talk about this after lunch, is that Thrips palmi screening, which is what we have in Taiwan, seems to be associated with Thrips parvispinus resistance. So our Thrips palmi resistant lines appear to be tolerant to Thrips parvispinus, this black Thrips you're mentioning. So I think they're the same genus, but it seems like this might hold up. That's different than what these two species are different than the predominant species of thrips affecting Chile in the past in India has been. Both of these. Yeah.
Thank you.
There is time for a very last, very quick question.
Hi, Derek. This is Sandeep from East West. I see good progress on heat set. And do you have any plan to combine heat set with other important traits like LCV or anthracnose? Because heat set alone cannot help us.
Right. And this is something that, this is the role that I see WorldVeg to play, is really pre-breeding to identify good sources of resistance to multiple stresses, combine those as best as we can, and then provide them to you to make the final product. This is my vision of WorldVeg pepper breeding. Now, we can discuss how that needs to change or how that should be in the future together, but as far as this relationship, that's kind of how I see it. But to do this, I'm confident that we have to work at it one at a time. If I'm screening for thrips, leaf curl virus, heat, all at the same time, I'm going to miss out on everything. So I work on heat, and then over here, I'm working on Bagomo virus. Over here, I'm working on thrips. At the end, well, at some point, they're combined, and then we go. This is my vision. Now, if there's feedback on this, I'm always open to discuss this.
Please let us discuss this feedback during the coffee break and during the lunch break. I'm very sorry, I need to interrupt the discussion at this point. Thank you very much, Derek.